Welcome to Brain Vision.
Had to delete some videos to make room for my recording. It didn't record the first time, only half of it, so let's try again. We are given a man has a mass of 85 kilograms and he plans to tow a 109,000 kilogram airplane. We can ignore this. He's pulling at a 9-degree angle above horizontal and a coefficient of friction between the man's shoe and the runway is 0.77. And we're asked to find the greatest acceleration the man can give the airplane, and we're assuming the wheels have no friction. I'm going to use 9.8 for the acceleration due to gravity. So here's just a quick sketch here, and that's just a sketch I did to get my horizontal components of the tension of T. Then, well, I should take a look here. If the man is pulling with the tension of T, so T times the cosine of theta will equal the acceleration, the man times A, or the mass of the airplane times A. That's the mass of the airplane times the acceleration of the airplane. Okay, then we did a quick sketch of the forces acting on the man. We've got a normal force, and then the mass of the man times G. Got the friction force, and then the tension force. These are T's from the previous page. Okay, so the vertical direction for the forces, we have the normal force times Ty times the mass of the man times G. That equals 0. Solving for n, and n will equal T times the sine of theta times the mass of the man plus G. So the friction force on the man will equal the normal force times mu, which will equal T times the sine of theta plus the mass of the man times G times the friction force. And I don't know why I have that G right there. Okay, so the mass of the man times the acceleration equals the friction force minus T times the cosine of theta. So the mass of the man times the acceleration, or this is the mass of the man times the acceleration, will equal T times the sine of theta plus the mass of the man times gravity times the coefficient of friction times T times the cosine of theta. Okay, so here's combining the equations. You can take a look at that equation. And here's a little solving, here's solving, and here I'm substituting into all my values. So I substituted 85 kilograms for the mass of the man. I should get a highlighter instead of using that. Okay, so the mass of the man, whoops. What am I doing wrong here? There we go. The mass of the man is 85 kilograms. G, 9.8 meters per second squared, and the coefficient of friction. Divide that by the sum of 85 kilograms, negative 109,000 kilograms for the airplane, times the tangent of theta, right there, plus the mass of the airplane. Put my values in, here we go, and I got 6.99 times 10 to the minus third meters per second squared.